In this example, we will be evaluating the square root of 104. To do this, we're going to find a tenths place decimal approximation that gives us approximately 104 when it's squared. So let's look for perfect squares nearby to 104 to start. 10 squared is 100, while 11 squared is 121. So we can see that 104 fits between 100 and 121. We can then write the following inequality. 100 is less than 104, which is less than 121. We can then take the square root of all of these values. The square root of 100 is 10, because 10 squared is 100. The square root of 121 is 11, because 11 squared is 121. Now we can see that 104 is between 10 and 11, or the square root of 104 is between 10 and 11. Now we can see that 104 is closer to 100, so the square root of 104 will be closer to 10. So we want to try out tens place decimals between 10 and 11 that when multiplied by themselves give us about 104. So let's try 10.2 squared, or 10.2 times 10.2. 2 times 2 is 4, 0 times 2 is 0, and 1 times 2 is 2. Add a 0 for the next row since it's multiplied by 0, and then do the last row. 1 times 2 is 2, 1 times 0 is 0, and then 1 times 1 is 1. Adding these together, we get 104.04, which we can approximate to 104. Now we can write 10.2 squared as approximately 104. Taking the square root of both sides, we'll cancel out the squared and the square root here to give us 10.2 is approximately the square root of 104. This will be our approximated solution.